So this video is on pre-processing text data. So we pre-process text data to standardize the format and to define what a unique feature is. So with text data, a feature is commonly a word or a character in some special cases. And if we have a small collection of text where we have 2,500 unique words, then we commonly say that the vocabulary is of size 2,500. And the number of features is equal to the size of the vocabulary. So one unique word is one feature. And for most types of analysis, we have to represent each feature with some numerical value. But this is where the importance of preprocessing comes in, because should the word try and trying have different values? Or do we think they convey the same basic information in the context that we are investigating? And what about spelling USA in large characters or in small characters? And are punctuations important? These are the kind of questions that we have to think about before we start to pre-process our texts. And when working with text as data, the number of features is much larger than when working with most other types of data because the vocabulary can be very large. And pre-processing is therefore both about standardizing the data and also about trying to reduce the number of features to relieve the computational cost. So the common pre-processing steps are these 4 steps. So firstly, we'll do some segmentation, which is basically about dividing the text into the words or whatever entities that you're working with, whether it's words or characters. I'll explain this, as you can see, in a bit, and the next thing I'll talk about is lower casing, and then we'll talk about stemming and lemmatizing, and lastly I'll talk about removing what's called stop words and also removing punctuations and other types of text patterns. Let's start with tokenization or segmentation. So to be able to work with text, we have to divide the string that we are given into some meaningful segments that will most often, and in the case of what we're doing in this notebook, is words. So we'll divide it into words, and each of these words are called a token. So in this code, we'll just take the first sentence of our training set, and if you run this code block, you'll see it printed here. So this is the first review, which is apparently about a movie called Forbidden Siren. And here I show the most basic way of doing word tokenization, which is just saying that we'll split the string at each white space. And you can see the result here. So each time there's a white space, we'll split the string, and the result will be a list of these words, or of tokens. Okay, so another way of doing word tokenization is to use a package such as NLTK, which is just a bit more knowledgeable. And if you compare the output, you can see here where we just split at white space, we'll end up with tokens that looks like this. So if we look at the NLTK output, you'll see that it will also split with when symbols are close together. You can also do segmentation at the sentence level, which you can also do with NLTK. You might have a document with a lot of sentences, and you might want to work with sentences rather than whole documents. Like the simple way of doing sentence segmentation is just by splitting at the dot. Okay, so the next subject is stemming and lemmatizing. So stemming is just about stripping the word down to its central meaning, which is its stem, by removing affixes. And stemming usually only removes suffixes, which is affixes at the end of the word. So for example, you'll see the word sings will become sing, the word laughing will become laugh, And the word wonderful will become wonder. So this is what I talked about earlier, that we may want to say that some words such as try and trying have the same overall meaning in our data. So we can say that we want to remove all endings, and then these two words will be the same token and have the same ID. And lemmatizing is along the same line. It's the task of determining that two words have the same root despite their surface differences. So for example, here the words sang, sung, and sings are the forms of the verb sing. And then with the lemmatization, we will transform the words sang and sung and sings into the word sing, because that's the common lemma of these words. Okay, so we'll start with an example of how to stem the text. And the most simple way of doing this is by defining a set of endings and then removing these endings. So that's what we're doing here. We're firstly tokenizing the text, and then we're using this function here, which uses a regular expression to return the stems without the endings. And firstly here I'm printing the tokens. And we'll see, for example, that the word based has now been changed to bass. And this isn't really that good. We also see that the word movies is changed to move, because this is a very naive way of doing the stemming. What we can do instead is that we can use a function from NLTK again, called Porter stemmer. You can also find other stemmers from other packages, but we'll try and see the output of using this function instead. Okay, so if we look at the output here, we see now that instead of outputting bass, we output bass. But bass is also another word. Now we'll have the word base signifying maybe a military base will now have the same meaning as the word based. So this is also a bit flawed method, but still we will have some kind of standardization. For example, we'll have that the word translate and translation and translating will all be defined by this token, which could be good for reducing the number of features that we have in our text. And you really see that stemming has a large impact on how your data looks like. Now let's go on to how to lemmatize text and what that output looks like. So again, we'll use a function from NLTK to lemmatize the tokens. And firstly, I'm outputting the sentence. Maybe I should output the tokens instead. So these are the standard tokens without any processing, and here we see the lemmatized version. We see that lemmatization changes the data a lot less than stemming does. And with lemmatization, we'll keep the word based as it is, because we're recognizing that the words based and base are not the same, does not have the same root meaning. Okay, so now we come to some other quite important steps of preprocessing, which is about casing, stop words, and punctuation. Lower casing is a very normal preprocessing step. Basically, you want the word such as that appears after punctuation, and the word that to be treated the same. So you don't want these two to be defined as two different features just because one has a big T and one has a small t. And if you don't lowercase your text, that will be the case, that these two words will be treated as different features. So you can lowercase a sentence or a string just by saying .lower. So let's see the result here. so there are some exceptions where actually the upper and lower casing of words is important. For example, when we lowercase a text where we have US in upper cases, then that becomes the same word as us, and we know that US and us have two different meanings, so that can be a problem for some tasks, but for other tasks it may not matter. Here's how to lowercase and tokenize all text in the training set with a list comprehension. You should run this block of code because we're gonna be using these train sentences and test sentences in some of the later cells of in this notebook. So another common step is to remove certain words that we call stop words. And stop words are commonly sort of filler words. It's words that are very frequent, but doesn't give much meaning to the text. And in principle, we can say that any word is a stop word if we want to remove it from our text. But we can find a list of common stop words that people would often remove from the text data. And we can find such a list from NLTK here, and let's look at it. So you can see these words that you will recognize are often just words that will be very frequent in the English language. So what you'll see here is a very common way of doing a basic pre-processing of a piece of text. So in this list comprehension, I'm taking the first sentence of the training set, and I am lowercasing it, and I'm tokenizing it, and then I'm checking whether some of the words are in this stop words list that we've defined up here, and then we'll only keep the words that are not in our stop word lists, and you'll see the result here. Lastly, you want to consider whether you want to remove punctuation, because maybe you don't find that punctuation is important for your task at hand. So maybe you want to remove commas and dots and slashes. And I've given you some ways of doing that here. And when you're working with text data, it's quite useful to know something about regular expressions, because you'll often use that when you want to remove certain patterns in your in your text. For example, these patterns here, which are an element of the HTML that has passed through and is still in the text. When you want to remove stuff like that, you might want to use some regular expressions. So here's a link if you want to dive into learning something about how to use Python regular expressions. Okay, so let's try and look at how the sentence that hasn't been pre-processed looks like when removing punctuations. So it looks like this, and you'll see that there are some stuff that you should be aware of, such as this BR has just been appended to the word before it, because there was probably just one symbol between this BR and whaling. So again, in this case with this data, you may want to try to remove patterns such as this. Okay, so now that you've been introduced to the fundamental pre-processing steps, you should make your own function here, where you put together what you've learned, and feel free to add whatever you think could be important for the text data that we have. So let's have a look at the size of the vocabulary of the training data that has only been lowercased and tokenized. And what I'm doing here is I'm making a dictionary in which I'm filling in all the words that are in our training sentences, all the tokens. And then I'm counting the number of times each unique token appears. And then the vocabulary will be equal to the keys of our dictionary. And then we can see how big our dictionary is by printing the length of this vocabulary. Okay, so Right now, we have in our training data 111,836 unique tokens. So that's quite a large vocabulary. And then we can, I'm here inspecting the 10 most frequent tokens, and we can see that the words the and also some punctuations and some other filler words are the most frequent words in this data that hasn't been pre-processed. Once you've made your pre-processing function, you should apply it to the whole training data and then do the same as I did here. Make a new vocabulary, and then you should see the difference in the most frequent tokens by running this code with the n that you choose.